Okay, so what we just saw in the previous segment was the total number of atoms. Now the total energy of all these members is going to be the sum of the product of the number density of oscillators in each energy level and the energy of each oscillator, blah blah blah, which basically means energy of 0th level into number of oscillators in level 0 plus energy of level 1 into number of oscillators in level 1 plus energy of level 2 into number of oscillators in level 2 plus so on. That is going to be the total energy. So that is that equation we have here, 0 into n naught plus epsilon into n naught x plus 2 epsilon into this, so on, where epsilon is the energy of the first level, 2 epsilon is the energy of the second level, 3 epsilon for the third level, and so on and so forth. And the number of oscillators in each level is given by n naught e raised to minus epsilon by kt, and that is what we assumed as x, remember. So n naught x. For the second level it will be n naught e raised to minus 2 epsilon by kt, so x squared. Third level n naught x cubed, and so on. So that is how we get this expression. Again, from here, if you notice carefully, n naught epsilon x are common terms. If you take that out, you get an expression of the form 1 plus 2x plus 3x square plus so on. This will again be an infinite series because, as I said, the number of energy states is infinite. And again, from mathematical proofs, it has been shown that the expansion for this series is 1 by 1 minus x the whole square. So what is our expression for total energy? N naught epsilon x divided by 1 minus x the whole squared, where x stands for e raised to minus epsilon by kt. This is what we have derived so far. So we have derived up to this point so far, and we got this expression n naught epsilon x by 1 minus x the whole squared. Now this can be split into n naught by 1 minus x, epsilon x by 1 minus x. And this n naught by 1 minus x looks familiar, right? We just derived it here. So what is this? The total number of atoms n is equal to n naught by 1 minus x. So can I replace this term by n? It makes sense, right? So n epsilon x by 1 minus x. So this x is taken down to the numerator, that's why it becomes n epsilon by 1 by x minus 1. Again, what have we done here? We had this, we split it into n naught by 1 minus x, epsilon x by 1 minus x. This is equal to n, total number of oscillators, which we derived in the previous slide. So I am replacing this by n. We again have epsilon x by 1 minus x. Taking the x to the bottom, we get n epsilon by x inverse minus 1. So this is the expression for the total energy. Now what he wants to find out is average energy per oscillator. Remember, he wanted to find out two things: average energy of one oscillator and the total number of oscillators. Now we'll first find out average energy per oscillator, and then I'll go back and explain a certain caveat there. So average energy per oscillator is what we need to find out. We know this is the total energy of all oscillators, and we know n stands for the total number of oscillators. So for average energy, we simply divide this by n. So you get epsilon by x inverse minus 1, where x was nothing but e to the power minus epsilon by kt. So your final expression for average energy per oscillator is epsilon divided by e to the power epsilon by kt minus 1. And again, epsilon was just a notation we use for h nu. So your final expression for energy per oscillator is h nu divided by e to the power h nu by kt minus 1.